2-liter Coke bottle. And to do so, our dad told us that this information would help us. So Google says that 150 psi will rupture a Coke bottle. So to generate this pressure, we'll use the chemical reaction of aluminum plus hydrochloric acid, which turns into aluminum chloride and hydrogen. So we know that pressure, volume, number of moles, and temperature are all related in the ideal gas law. So we have 200 pressure to be safe. Multiply that by the 2 liters. We're trying to find the number of moles, and then the temperature is 60 degrees Fahrenheit or 15.5 degrees Celsius. Once you solve that, you know that the amount of hydrogen you need to rupture a Coke bottle is 1.149 moles of hydrogen. So you multiply that by the stoichiometric ratio of 2 moles of aluminum per 3 moles of hydrogen, which equals 0.766 moles of aluminum. So you multiply that by this molar mass of 26.98 grams of aluminum per moles of aluminum, which equals 21 grams, or to make sure it explodes, 30 grams of aluminum. Now we have to find the amount of acid we need. So using our 0.766 moles of aluminum, we multiply that by the stoichiometric ratio of 6 moles of HCl per 2 moles of aluminum. That gets us 2.298 moles of HCl. We multiply that by the molar mass to get 83.87 grams of HCl. Now, we have a 30% solution. So, to find the amount we need, we'll set it up in this ratio to find for X. X ends up equaling 280 milliliters. And to make sure it explodes, we'll use 350 milliliters of HCl.
We measured that we needed 30 grams of aluminum foil for the bottle to explode. So we got aluminum foil and measured how much we needed. Then we put the aluminum foil in the bottle. Now, my dad will add 350 milliliters of hydrochloric acid into the beaker and add it to the mix. Alright, so here's how to blow up a Coke bottle. Google says 150 psi will blow it up. So we were just going safe with 200. So then we know that there's 200 psi and the volume is 2 liters. And the number of moles, we don't know, we're trying to figure it out. And we know that the temperature is 60 Fahrenheit or 15.5 Celsius in Germany. And so what we did with the mole is we found out on Google that it's that. So then we did cross multiplication and we got 7.66. So then we did that over a mole, we got 26.98 G aluminum equals 2 LGs. So 21 LGs. So what we just thought, just to play safe, go to 30. Down here, since we got that number from right there, we did 6 mole over 2 mole, but then you get that, 2.298 mole HCl, and then since you have to figure that out, and you get 36.59 over a mole, which equals 83.87 HCl. So then, you would have to go over here, and you'd see 30. So then we had 30, right? So we were trying to figure out how much we needed. So then you do over that. So then you do 30x equals 8,400, and it's 280 milliliters. So we were just playing safe, and we went with 350.